And let's talk about Gouge check. Let me generate this toolpath first. So it's going to run. Okay, there's my toolpath. As you can see, let me go in and change the step over direction. Please type in your questions if you have any questions, and I might be giving you a lot of information here, so I want you to make this as interactive as possible. So I changed the step over direction, step over control amount, which basically controls the distance between two successive cuts. And as you can see, it's a really nice toolpath. But as you can see, these gray surfaces down here are being machined, which we don't want. And the reason this little boss that's sticking out is not machined is because it's not part of the control geometry. I didn't select that as the drive geometry, so it's fine. So how do we avoid these? So that's the other set of control geometry that we have in 5-axis, which we call Gouge check geometry or check geometry. So basically we can tell the system that, hey, I want to machine these surfaces, but I want to avoid these surfaces. So basically check against them. So I'm going to add these surfaces as my check surface. I'm going to select them. If it's a poly surface, it's probably easier to select the. Okay, let me select that. Let me, for the sake of, I don't want to select that for now to keep it quick. And then we also have a gouge check strategy. So we can leave out the cutting gouging points. We can retract along the tool axis and by a clearance and not machine those surfaces. Let me do this first. If I do that, it's still machining. As you can see, it's avoiding that gouge check geometry that I selected. So that's very similar to the way it handles this boss, because I did not select it in the surface geometry to machine. But here we're actually specifying this to be avoided. And the other thing I can do is, instead of doing that, if you don't like the way it picks up over that control geometry, I can go back in there and change my gouge check strategy to actually retract along the tool axis. That might give you a better tool path and a lot less vibrations in the tool. So here, basically, we're moving up above that surface and not and avoiding it completely. So those are the two types of, or three types of control geometry, if you will, that we have in 5-axis mode. A little bit different than in 3-axis. So we have the drive surface. Drive surfaces define your cut pattern, not only your cut pattern, but also your tool axis vectors by taking the surface normals from the drive surface. And then you have drive curves, which actually, depending on the way you select it, they define the cut pattern on the tool surface, on the drive surfaces that you've selected. And finally, we have the gouge check surfaces or check surfaces that are the surfaces that you want to avoid. So these are the three types of control geometry that we have in 5-axis mode. It's a little bit different than the 3-axis mode. That's why we spent a lot of time trying to make that distinction.